So, the adaptive course of physics in a technical university. The qualitative higher technical education has in its basis the knowledge of physics and mathematics. But according to numerous publications and our observation, some students lack the basic knowledge in elementary physics, so they have problems in mastering physics of the technical university syllabus at the corresponding level. Such gap of knowledge has a vital influence on the formation of engineering thinking and determine the low level of the professional qualities. It is possible to lessen the gap between the actual levels of students' knowledge and the knowledge needed to study physics at the university by means of the adaptive course. Such course by now is not included in the syllabi and curriculums, and its organization must be supported mostly by the independent students' works with the educating materials. Having organized this kind of work using the telecommunication technologies, periodic communication with the teacher in the classroom gives the lecturer possibility to involve more students into the work. Those students who need overcoming the lack of knowledge and skills with the minimum usage of the classroom hours. In fact, such work in its form is the implementation of the blended learning. The purpose of our paper and our report is to present the methodology of organizing the work aimed at the diminishing gaps of knowledge in physics of the first-year students at the technical university with the help of blended learning techniques. We think that the most reliable information about the knowledge of physics among the school leavers present EAT results before the statistic processing, the so-called raw result. Using the results of the official reports during the period 2015-2019, we calculated the ratio of the average mark of the test to the possible maximum mark. Performing the EAT task on physics during the period from 2015 to 2019 is an average at the level of 32% of the maximum possible, as it can be seen on slide number 2. This clearly demonstrates the fact that potential students have considerable gaps in their knowledge. Most concern is caused by the fact that the open tasks that actually are not difficult ones are solved by not more than 15% or from 15 to 17% of the school leavers. To detect the gaps of knowledge among the first-year students, we developed the diagnostic technique. Look at slide number 3. The results of the survey delivered among the physics teachers allowed us to distinguish the reasons that cause the problems for students in studying physics at the technical universities can be seen from slide number 4. We assess the actual first-year students' level of knowledge in physics by the entry test delivered by online testing. The distribution of the marks in percent for 530 students of different faculties of Igor Sikorsky Kyiv Polytechnic Institute is presented in slide number 5. The general statistics of the entry test is slightly better than that of the EAT. However, most results gained by the students are not satisfactory according to the ECTS at the higher educational institution because most students cannot get the minimal positive mark E lying in the range of 60%. So, if we eliminate the gaps in the students' knowledge and improve their basic preparation in physics, this will improve the qualitative mastering of the material of the course of general physics at the technical university. In our opinion, the most expedient form of organizing the students' work to overcome the gaps in their basic preparation is the flipped classroom model of blended learning. In this model, students rotate on a fixed scheduled time, consultations, tutorials, and independent work with the instructions and materials in the format of the remote access during their out-of-classroom time. Besides, students can choose time, place, path, and/or pace, and the rhythm of their work with the internet resource. The generalized scheme developed by us of this model of students and teachers' work is presented at slide number 6. During the first week of the semester at the technical university, the lecturer informs students about the peculiarities of the subject, its demands, and asks the students to complete the online questionnaire and entry test on the subject. The students complete these tasks at home. The gaps detected by the entry test make it possible to plan the individual trajectories of the correction for the students, and these trajectories have the stages to correct theoretical knowledge and skills to solve the problems. Schematically, the work succession while developing individual trajectories is presented in slide number 7. During the second week, the lecturer sums up the results of students' work at home, and according to the testing results, defines the typical gaps in his or her physics knowledge due to the secondary school program. If necessary, the lecturer offers the students to have the adaptive course to overcome the problems at their wish. The goal of the course for the students is to repeat or study theoretical material and to acquire practical skills to apply their knowledge in physics and mathematics for solving problems under the EAT program according to the developed thematic plan. During the following period, the teacher gives students new tasks for the next weeks at the tutorials. The students, having the theme for independent study, repeat or learn theory, study of the methodological recommendations and examples of using these recommendations while solving physical problems. While solving test tasks and problems for the independent work, the students consolidate their theoretical knowledge. The final control of the weekly work is the test on the same subject. Due to these results, the lecturer can make necessary changes in the thematic plan or correct an individual trajectory of the work of the particular student. During face-to-face consultation, the students can have any explanation of the not understood questions. To involve the students with the gaps in basic knowledge into such a control system and to motivate their diligent work, there are bonus marks in the ICTERI or the adapted course program. To put into practice the proposed methodological approach of building up and correcting students' knowledge and skills while solving physical problems, we developed the E-complex. It's slide number 8. It includes the thematic plan, the manual, and the system of testing tasks. These materials are located in the LMS Moodle on the special site of the Department of General Physics and Solid-State Physics, Igor Sikorsky Kyiv Polytechnic Institute, Faculty of Physics and Mathematics. The content of the manual depicts the traditional logics of studying physics at school. That is why it consists of 6 parts: mechanics, molecular physics and thermodynamics, electrodynamics, vibration and waves, optics, modern physics. Each chapter is divided into the content units. That is, each content unit consists of brief theoretical material needed for the solution of the problems of this content unit, methodological recommendations for the problem solution, examples of problems solution, tasks of problems for independent work, and additional information block. To our mind, a thematic plan, it's slide 11, has the optimal program division corresponding to each educational week. Such division, from one hand, guarantees deep enough work on the educational material and, on the other hand, quick revision. There are, corresponding to each topic, it's column 1, indicated chapters, column 2, where students can find the related theoretical material. Using the thematic plan and the manual helped us to involve students into the educational process of acquiring important skills for the future engineers to solve problems. And we got the possibility to predict and take into account their work results. Control is one of the important pedagogical conditions to ensure the feedback. Structurally, the control of educational achievements has the following. Look at slide 12. The system of tests to monitor the educational activity of students during the adapted course is composed of the same parts as a handbook. Each part is divided into units. Students took online testing in the appropriate time and place, at home, in the library, etc. Such approach gave the possibility for the students to check their level of mastering the material according to the thematic plan. The regular testing control of knowledge of physics stimulated the independent work of students and gave the possibility for the teachers to monitor the dynamics of overcoming the detected problems in the competence under the secondary school program. And now let's move on to the results of our research. To understand and clarify the role of the adaptive course while mastering the basic skills in physics, we delivered the survey among the students of the Faculty of Heat and Power Engineering of the Igor Sikorsky Kyiv Polytechnic Institute at the end of the course of physics. 133 students took part in this survey. The analysis of the students' questionnaire results after finishing their work with the adaptive course showed that 51% of them considered the course to be helpful in better understanding theoretical material on physics under the frame of the syllabus of a technical university and helps them to pass a final exam. It was chosen 3 criteria to check the effectiveness and the influence of the methodological approaches and teaching materials under the frame of the adaptive course developed for the technology of the blended learning on the students' achievements. Slide number 14. The results of the delivered mass processing of the obtained data during the experimental work on every indicator of the chosen criteria are presented in our slides 15, 16, and 17. Having compared the critical and empirical values, we found out that it was twice bigger than the critical meaning for all the criteria. That is why we made the conclusions about the significance of the changes of the figures of the respondents in control and experimental groups after delivering the pedagogical experiment. So we can state that the results of the research experimental work prove the unbiased nature of the chosen approach to improve the effectiveness in teaching physics for the students and eliminate the gaps in their previous learning of physics. Thank you for your attention.